Hi there, welcome to highschoolmaths.co.uk. Today we're going to be looking at how to find the equation of a straight line and various other things we can do with the equation of a straight line. So we're going to look at, first of all, finding the equation given any 2 points in a straight line, and we're just going to work through these two examples using the exact same methods so you can see how similar it can be. Now there's various tweaks and stuff you can do to make it a little bit easier sometimes, but we're going to stick to one method that works for all questions. So we're going to break it down into 3 steps, the first step being finding the gradient using the gradient formula. So that's m equals y2 minus y1 over x2 minus x1, where your coordinates are x1 and y1 and x2 and y2. Now all you've got to do is pop these numbers in the correct place in the formula. So 11 take away 1 on the top line for y2 minus y1 and 5 take away 0 on the bottom. 11 take away 1 on top is 10, 5 take away 0 is 5, so we get 10 divided by 5, which is 2. So a gradient of 2 for this straight line. The second step here is to find the y-intercept. Now the way we're going to do this here can be shortened for this question, but that won't work for all questions, so we're just going to stick to a routine. We know that the equation of the line is y equals mx plus c. Now what we calculated was that m was 2, so for this particular line we're going to replace the m with a 2, and we know that y equals 2x plus c. Now what this is saying is the y coordinate is going to be 2 times the x coordinate plus c. So what we want to do is try and find out what c is, and to do that we're going to choose a y coordinate and a corresponding x coordinate. Now this comes from either of your first 2 coordinates, so we can choose this one or this one, and we'll get the same answer each time. Now I'm going to choose this one because it's lower numbers, but the other one will work fine too. So we're going to take the y value from here, that's 1 equals 2 times the x value, which was 0, plus c. Simplifying that, 2 times 0 is 0, plus c. And at that stage, we've got 1 equals 0 plus c. 0 plus c is just c, so c equals 1. So the second step is finding a y-intercept. The third step is to then put that information into the final equation. So y equals mx plus c would be y equals 2 for the gradient, x plus the y-intercept, which is 1. So that's the equation of our straight line there. Let's have a look at how that works with a different example. Now, going back to this first question, y equals 2x plus 1 means the gradient is 2 and the y-intercept is 1. The y-intercept will always be the point where it crosses the y-axis, so it will always be 0 something. That's how we know the y-intercept here was 1. We could have just read that value off from this coordinate, okay, and that would have saved us a little bit of time, but that's not going to work with a second example because we've not got a 0 coordinate, we've not got 0 something. So let's have a look at it. Again, first step, find the gradient. So gradient formula, label your coordinates, pop the numbers in the correct place. So negative 10 minus 5 on top, 3 minus minus 2 on bottom. That's minus 15 on top over 5 on bottom. So we've got a negative gradient here. That's going to give us negative 3. Second step, find the y-intercept. So we know that y equals mx plus c, and in this case, so the m was negative 3. So we're going to choose one of the original sets of coordinates. Neither are really kind of any easier than the other. I'll pick the lower numbers again, so I'll pick the first one. The y coordinate was 5 equals negative 3 times the x coordinate, which is negative 2, plus c, which we don't know yet. C is our y-intercept, remember. So 5 equals negative 3 times negative 2 gives us a positive 6, so 6 plus c. This time's a little bit trickier, but not much. We just want to get c on its own, so we're going to take away 6 from both sides, and that tells us negative 1 equals c, or c equals negative 1. And to finish that off, we've got y equals mx plus c as our general form of the equation. So y equals negative 3x. Now don't write plus minus 1, just minus 1 as our final equation there. Okay, so that's how you find the equation of a straight line joining any 2 points, and that method will work for any 2 points on a straight line. You can follow that through. The only thing that's going to change is the numbers. Now, There are two different common equations or structures that you use to find the equation of a straight line y equals mx plus c, or slightly more complicated looking but probably more useful in some instances, y minus b equals m bracket x minus a. Now, we can use these in various ways, and we're going to see that in these questions here. So we're going to just jump straight in. We've got an example that says find the gradient and y-intercept of the lines with equation. Now, these equations have been rearranged. They're not in the form y equals mx plus c, which is the form we need if we want to read off the gradient and y-intercept. So if we flick back a page, here we can see from our final line here on the second example that the gradient was minus 3 and the y-intercept was minus 1, which is what we got in our working. Now that was fine because it was in that form y equals mx plus c. These aren't, so what we've got to do is we've got to change the subject of the formula or rearrange the equation. So 4x plus 2y equals negative 5. What we want to do first is get the 2y on its own. That means we're going to take away 4x from both sides. So I'm going to take away the 4x from this side. I'm going to take away a 4x from this side. Now there's nothing to combine that with, so I'm going to put the minus 4x first and then keep the minus 5 on this side where it was. So we get 2y equals negative 4x minus 5. Essentially the 4x has just gone over here and become a minus 4x. Now, we're not quite finished there because the equation of a straight line should be y equals, not 2y equals. So we've got to divide everything by 2. And if we do that, we're going to get, divide this by 2, that becomes y. Divide this by 2, that's going to become negative 2x. Divide this by 2, that's going to become negative 5 over 2, or negative 2.5. I would prefer avoiding decimals where possible, so I'm going to stick to the fraction here. Now, from that, we can see, remember it's y equals mx, so this is our gradient, so m equals negative 2, and this is our y-intercept plus c. So c equals negative 5 over 2, or negative 2.5. That's the gradient and the y-intercept of this line. Similar idea with the second one, so we want to try and get the 3y on its own here. First of all, now actually there's a really an easier way to do this here. If instead of trying to move the x and the 7, it makes more sense just to move them negative 3y. So what I'm going to do is the opposite of negative, taking away 3y is adding 3y. So I'm going to add 3y to both sides. The x is going to stay where it is. I'm adding 3y to this, so that will cancel, leaving 0. The plus 7 is staying where it is. If I add 3y to this side of the equation, I've got to add 3y to this side. And again, really all you're doing is moving that negative 3y across here, it's becoming a plus 3y. X and 7 are staying where they are. Now I'm going to flip this because that's not the typical way we would see this written, so it would be 3y equals x plus 7. That's just flipping the whole equation round. And again, we've not got that y on its own, so what we want to do is divide by 3 for this last line. Here, remember that's a 1x, so if we divide that by 3, it's going to be a third x plus 7 over 3. And again, once we've got y equals mx plus c, we can just read off our gradient. So m equals 1/3, and our y-intercept c equals 7 over 3. Remember, the gradient is always the number before the x term, or the coefficient of the x term here. Let's have a look at one more final example. So we've got find the y-intercept of the line with gradient 2 that passes through the point 11, 2. This is where the second equation, the y minus b equals mx minus a, this one here, is more useful because we've got a gradient, that's our m, and we've got an a and a b value, a point on the line. So that gives us the information we need for that particular formula. So let's write that down. Y minus b equals m bracket x minus a. And let's substitute in everything we know. So it's y minus 12 equals m bracket x minus a, which was 11. Now what we're going to do is just work through that and simplify it. It's asking us to find the y-intercept. I'm not sure how we're going to get there yet, but we'll see what we can do with the information we've been given. So y minus 12 equals 2x minus 22. Now what we want to try and do is tidy this up, collect like terms. So I'm going to now add 12 to both sides. I'm just going to try and get this y term on its own. So if I add 12 here, I'm going to add 12 to the number here. That's going to give me y equals 2x minus 10. And if you look at that format, that's actually y equals mx plus c. So here, this is our gradient, and the thing it was asking for is this part here, which is our y-intercept. So our y-intercept, the plus c, is minus 10 here. And that's us answered the question c equals minus 10. Because it was asking for the y-intercept, we're going to write that as a coordinate. So the y-intercept was 0, minus 10. Remember, the y-intercept always starts with a 0 for the x-coordinate, and then the y-coordinate will be wherever it crosses the line. Okay, so that's a variety of different ways you can use the straight line formulas in different situations. There are lots of other kind of tweaks on that, but it all kind of centres around that information there. Hopefully you found that useful, and for other resources and videos, please visit highschoolmaths.co.uk. If you like the video, click that like button and subscribe, and please remember and share the video. Thanks for watching, and have a mathemagical day.